Hello, I got one of these Orange Pi Zero super small low power Linux boards yesterday, and by the end of the day I managed to get quite a few things up and running on it, much quicker than I thought I would. So I thought I'd make a video to explain what I did in every little step, and hopefully that will serve as a sort of a tutorial, I guess, for other people who can't be bothered, searching Google and finding all the necessary links and stuff themselves. It'll all be in one place, but also partially as a future reference for myself. All of the info will just be in this video, and I can quickly come back to it and run through it again on any other boards of these that I buy in the future, because I got to say, I really like it so far. It's sort of a Raspberry Pi competitor, you might say, and in fact this pin header here is pin compatible with the Raspberry Pi, but from what I can tell, they're generally a little bit cheaper than the Raspberry Pi. Mainly, well, partially I guess because they are very poorly supported in documentation and also firmware from the manufacturers of these themselves. But fortunately there's something called Armbian which runs beautifully on this, so that's what I'll be using in this tutorial. And I managed to get GPIO interacting, so I could send, or I can turn an LED on and off and sense when a pin goes high and stuff. And I also managed to get serial UART working, and I did that with both C using an Arduino style programming and also with JavaScript using nodejs. So I'll go all the way through to that, starting from basically just taking it out of the box and going through every little step up to interacting with, I think we might even try interacting with the GPS module, because I got that to work as well. So that's what I'm going to do in this video, and we're going to be looking at Linux consoles a lot. In fact, there's no HDMI on this thing, so there's no way we can get it to do a desktop as far as I know. It's just going to be Linux server, and almost all of what we're going to be doing in this video is just looking at a Linux terminal. So it might not be your kind of video if you're not into that, but if you are a bit of a Linux user, then it's not going to be an issue for you, I think. Anyway, this particular board here is the 256 megabyte, yes, it's pretty small memory, you can see there, 256 meg. Pi Zero, and I think it's the smallest one that they make. I'm not sure if there's any smaller than this, and I was interested in this because it has just about all the features that I wanted and not really much more. So there's a wired Ethernet, there's just one USB, there is USB on the go which you can use there, and that also can be used to power this from a typical USB power. And it also turns out that when you connect this to a computer, this opens up a serial port on there which you can actually use to communicate with the computer here using a serial terminal. So you can actually use the Arduino IDE serial monitor to talk to this initially, and we'll try that in a minute. This is a 1.2 gigahertz quad core apparently, and the performance is okay. It's not as good as the Odroid that I've been using for other things, but it's okay. I couldn't do much compiling on it. I tried to compile Node.js, and it just literally could not do it. Just ran out of memory and started, I don't know what it was doing, but it just took about an hour and it never finished, so I just gave up on that and used the prepackaged Node.js. Anyway, another reason that I was interested in this particular one is we can see that there is a non-PCB antenna for the Wi-Fi, so it's actually a proper antenna that can be detached and replaced with something else. So that was something that interested me as well. And I like the fact that the pin header is pin compatible with Raspberry Pi, because that means that a lot of Raspberry Pi software and stuff out there should be able to do, or should be compatible with the kind of inputs and outputs that we have on here, and maybe even stuff that you can plug in to fit these pins might be able to use with this as well. Now, I mentioned that it was cheap, and this particular one I got here in New Zealand because I was trying to get it one quickly, and I discovered it's not actually on here anymore, but this one here, well, here we go. This is the 512 megabyte version, so it's a little bit more than what I paid. I actually only paid $17 for the thing itself and $4 for shipping, so I got this in the hand for 21 New Zealand dollars, which is just under 15 US dollars. So I was quite impressed with the price for what I got. If you don't live in New Zealand or you want to get it from somewhere else, there's also this is the same. Actually, this is the 512 megabyte board, so it's a little bit better than my one. And it's, again, pretty cheap on Banggood, so you can get it there. And the official software releases for this thing can be found here. But even though there are a lot of them, it looks like somebody's been quite busy making them. If we come down here, there are this one here, Orange Pi Zero. I tried this one here, Ubuntu Server, and it just didn't do squat. It didn't do anything at all. And I've seen a couple of other videos on YouTube where people tried this and they just gave up on it. So my advice would be just forget about this page completely and go on to something called Armbian, Linux for ARM development boards. And the one I am about to use is this one here, Ubuntu Server. So download that. It's just over a gigabyte download. So once you've downloaded that disk image, you'll need to put it onto a USB micro SD card. A micro SD card. So forgot to mention that, but I think we saw it before. There's a micro SD socket on there, and that's what we're going to be using as our hard disk. So once you've downloaded it, this is the file here. You'll unzip it into this, and there's a bunch of things in there, but oh yeah, this is the file we want here, image. And I'm using something called Etcher, which is a really nice program, and this will take care of writing it to your SD card so that it can be booted as a Linux distribution. So we'll select image, and you can see I've been doing this already because it's just finding that file for me, that one with image. And if you just have one SD card plugged into your computer, it should find that for you. And it's just showing me this 32 gigabyte SD card that I'm going to use. And then you'll click on Flash. I just did this before, so I don't need to do it now. It takes about 3 or 4 minutes maybe to finish. And then you should have an SD card ready to plug into the Orange Pi and get started. So I have my SD card plugged in there now, and I've connected it to my desktop computer for power and also to talk to it with, as we'll see in a minute. And it's been running for a couple of minutes, so should be ready to go. And there's a green light solid there and a red light giving 2 flashes. Not actually sure what the significance of those is, but I think when the red light starts flashing, it's ready to use. So the first thing that we want to try and do with this is, well, eventually we want to make a network connection, either through Wi-Fi or through the wired connection. But in order to do that, we need to know what the IP address is of the computer so that we can SSH into it and use the terminal to talk to it. Obviously, we are not connected to Wi-Fi because we don't have our Wi-Fi password set, and it doesn't know anything about which Wi-Fi router to use. So we need to either plug this in and figure out which IP address the computer was given, and then we can talk to it that way and set up the Wi-Fi. Another way that we can do it, well, there's actually a couple of other ways. One way is to use this, which we're about to do. But apparently you can also use these 3 plugs here, which are a ground, an RX, and a TX. So you can also talk to it using those. If you have a FTDI adapter or an Arduino, I guess you could channel through an Arduino to talk to it. But what I'm going to do now is use this one. And I don't want to do this method in the future. This is just a one-off thing so that I can figure out which IP address the Ethernet will be given. And it won't be anything at the moment, but I'll just show you how it would work. I'm going to use the Arduino IDE to do this because it has a serial connection. And before I plugged the Orange Pi in, this TTY ACM0 was not there. So now that it's showed up, I'm pretty sure that that is my Orange Pi. And when I open the serial monitor, we'll see that it spits out this little bit of text here. So now we're sort of looking at almost like a Linux terminal, and we can log in as, I think we have to log in as root to begin with. Password for root is 1234 by default. Now it's telling me I need to change the password. Let me just switch over to here. Now this page here was a huge help for me when I was going through this, so I'll put a link to this in the description. And you can see he's gone over this pretty thoroughly with nice photos and everything as well. So this is what I was saying before. You can use the sort of a USB to serial adapter like that to talk to it. and he is on Windows, so he's using PuTTY. And PuTTY will give us a nice display like that instead of the horrible one that we see in the Arduino serial monitor. But basically we're doing the same thing. So you type in root and then 1234 by default, and then you need to change your root password. So let me just go and do that. Now current Unix password, let's get it right this time. 1234. New password is I am root. I am root. Oh, come on. Root 4321. This is probably going to be too easy. 4321. Alright, so it's let us use that password, and it's also going to ask us for a username here as well. So you can see already that the formatting in the display that we see in this Arduino serial monitor is not very good. So I'm going to call this one Chris for my name, and a user Unix password for Chris will just be Chris. Yes. Alright, and it's asking us for a name. You don't have to put this stuff in, but I'll just say, is it correct? Yes. Alright, so now we can see things like this, and we can do this. Oops. Info. I don't have tab complete, unfortunately, but you can see a little bit of information about what kind of a system we're running here. Now the reason that I wanted to do this just once at the beginning was to find out what the IP address is of the computer on the network, so that I can connect with a proper network connection. So I would do something like ifconfig, and it will say, at the moment it's not going to show me anything because I'm not connected by Wi-Fi, and I'm also not connected by wired Ethernet. So right now what we're looking at, this is not useful, but what I'm going to have to do is take this down to the other end of the house where my Wi-Fi router is and plug it in to the wired connection, and if I had it set up in that state, then we would see this Ethernet 0 connection would show us an IP address, and then I'd be able to connect to that with a proper terminal to look at it in a much nicer display. So that's one way you can find your IP address. There are a couple of other ways which I will show you, but first I have to go and take this down to the other end of the house and plug it into the router. Right, so I connected the Orange Pi to my router and turned it on, so it should have obtained an IP address by now. There's nothing to look at here anymore. But there are a couple of ways now that we can figure out what the IP address is of the Orange Pi. One way you can do this is with Nmap, and this is a facility for searching for hosts on the network and also port scanning as well. So obviously this is only going to work if you're on Linux, but actually, what does this SN mean? I think it means map. Pings disable port scan. Oh yeah. We don't want a port scan. We just want to find hosts on the network. And the network for me is 192.168.1. And then you give the last part a 0 because that's what we're searching, and you want to fix the first 24 bits. I think that's what this means. I just found this somewhere on the net as well. So it's just going to look for hosts on the network, and I'm pretty sure it's that one because that one was not there before when I tried this. And I'm also pretty sure I know what these 100, 101, and 102 ones are. So I'm pretty sure it's that. And a couple of other ways that you can check this is using this Android app called Fing, like that. And this basically does exactly what we just saw the Linux one do. And it'll show you the hosts that are on your network there, which don't want to focus, but there we go. So the one at the bottom there that just says generic, that 107 I think is the one. Some of them, it gives you a little bit more information about what the thing is, like that. And finally, another way which you may be able to use is to log into your router itself, and some of them will be able to show you which devices or which IP addresses are in use. My one only shows you the wireless connections here, so this 101, 100 and 102, these are obviously my Android phone and my tablet. There's no 107 showing up there, so that looks like that 107 is a wired connection, so I think it's pretty likely that that is the one that we want. So let's give that a try. I'm going to be Chris at 192.168.1.107, and now we should be able to see. Please work. Yes. Yeah. Now we should be able to see the nice colors and the nice formatting. This is what the Arduino serial monitor was trying to show us before, but it just couldn't do it with all this nice formatting. So let's quickly jump back to that beginner's guide again and carry on with the next few steps. Just a few little things we can do at the beginning. Where are we? Initial configuration. Here we go. So we can update to get the latest version. So let's try that. Sudo apt get update. This can take a while, so I'll just fast forward this part. Actually, that didn't take very long. Maybe this one was the one that takes a while. Upgrade. Okay, so that took about 5 or 6 minutes, and at this point we have some basic stuff like GCC, and we also have Git, I believe. Yep. Sorry, am I going a bit fast? Git was what I did there. So we have some basics. Let's continue on with this sort of tutorial that we're doing. Reconfigure time zone. TZ data. So this will let you just set up your local time zone if you want to. There we go. What else have we got? Oh yeah. So this is what we're working towards at the first stage of this, isn't it? We want to have Wi-Fi access. So we're going to have to edit this file, etc network interfaces, and add a little bit here. This is where I found that this tutorial did not actually work for me exactly as he's done it. So I'm going to show you what I did that did work and see how that goes. So firstly, I want to install Emacs editor because I don't like Nano and I don't like VI or any of those other ones. Okay, now that I have Emacs installed, I can edit this etc network interfaces file, but I'm not going to do exactly what it says here for a couple of reasons. One is that, as we can see at the bottom of the page or the bottom of the screen, you can find out the IP address assigned to your Wi-Fi connection by typing that there. But that's not very convenient because if the Wi-Fi, the IP address of the Orange Pi changes in the future, we're going to have to keep figuring out what it is if we want to connect to it. So what I'd rather do is make it a static IP address. So that's what I'm going to do instead of using DHCP there. And the other problem with this is I found that when you enter your password in plain text in here, it doesn't work. You need to generate a sort of encrypted or a hashed version of your password, which is done by this, something called WPA passphrase, and then you'll put your SSID. So this is the name of your Wi-Fi access point as it shows up when you're searching for Wi-Fi access points, and then your password, your Wi-Fi password. And this will just spit out a little bit of text like this. So this PSK is what you need to put into your WPA password section there. Anyway, so let me edit that file, etc network. Actually, I might need to be sudo for that. Alright, now in here, instead of what he's got there, I'm going to paste in a bunch of things that I've used and found to work already. And why are they spaced out? Okay, so I'm going to explicitly set the IP address of this to be 111. And the rest of it's set up ready to go except for this here, which I'm going to change to my Wi-Fi access point name, and then just in case anybody comes snooping around trying to use my Wi-Fi, I'll paste in my hashed password here off screen and save this file. So with that file saved, I can do a reboot. There may be a smarter way to do this, but I've found that if you just reboot it, it will, of course it closes you out there, but I'll come back in a couple of minutes and try and connect, except this time I'm going to be connecting to 111, which should hopefully be the Wi-Fi connection rather than the wired connection. Okay, I've waited a couple of minutes now. Let's see if that works. Yep, that looks good. We're on Wi-Fi now. And if I do ifconfig now, we should see that we have the wired connection is 107, and then the wireless LAN connection down here is 111. So now I should be able to go down and unplug the Orange Pi from the Wi-Fi router and bring it back here to the desk to do some more interesting stuff with. Okay, so I've brought the Orange Pi back to the desk, and you can see we're not connected by Ethernet now, but nevertheless we can talk to it just fine. So is it working? Yeah. Was there anything else interesting on this page? I think there was something. Oh yeah. There's this thing called ambient monitor, which is quite handy for checking the temperature, I've found. Sudo ambient monitor. So right at the end here we can see that the CPU temperature is 47. I've seen this go up to about 64 when it's very busy, but generally it's sort of low 40s. Right, so that's the basic setup done. Now let's look at some of the other interesting things that I mentioned at the beginning. Actually, one thing I don't think I mentioned but is quite interesting is something called wave monitor. So if you do this, wavemon, I think. Not sure if this is on screen. So I'm just installing this thing called wavemon, which is very nice interface for measuring the Wi-Fi strength. So now we have something called wavemon, and this is really neat. So the link quality there is 64%, and you can see some other stats like how many packets have been sent and all that kind of stuff. Now if I put this over here a bit, and I just wanted to show you something. So link quality is 69%. If I cover up the antenna like that, it goes down to about 43 or so. And it does it pretty quickly. At least it goes down quickly. It doesn't come up quite as fast. But yeah, this is quite a neat little utility. Okay, let's have a look at how we can do some interaction with GPIO and UART serial port. And I'm going to do this in two ways. One is using C or C++, and I quite like that way because you can reuse a lot of your old Arduino code, because the library that, at least the one that I'm going to show you, is based off the same kind of library that forms the foundation of Arduino. And the other way that I'm going to try is using nodejs, so that lets you use JavaScript, and it makes it much easier to set something up as part of a web server so that you can interact with it through the web browser on another computer. So anyway, I have here, you can see I've plugged some things in. I have an LED. This is just a simple LED. There's actually a current limiting resistor in there as well, and that's going to a couple of pins on the pin header, and then we have another 4 pins used here. This is a GPS module, and I'm just going to turn the light off and on, so it's just the blink sketch from blink LED sketch from Arduino. Basically, we're going to try and reproduce that, and then just print out whatever data this GPS is sending to the Orange Pi. We just want to print that out on the terminal. So those are the two examples that I'm going to show you. And as far as the pins go, if you do a search for Orange Pi 0 pinout, you'll find stuff like this. I found this one to be the most useful so far. So the numbering of the pins is slightly different for the C++ version and the JavaScript versions. And I just sort of fiddled around and found this out by trial and error, but the 2 pins where I have my LED on are this ground and this one, which is labeled GPIO 6, and this number seems to be the one that you use for the Node.js interaction, and it's also physical pin number 7, and this physical pin number is what I found to succeed for the C++ slash Arduino version. And my UART connection is using these 4 pins here: 5-volt power, ground, and then this one here, it's a bit hard to read, but it says UART 1 TX, UART 1 RX, so those are where I've plugged everything into. So let's start with the C++ version first, because that'll probably be a little bit simpler for people coming from an Arduino background to understand. You need to first install something called wiring OP. This OP is for Orange Pi. It's ported from Raspberry Pi version of a similar name, and it's very easy to install. You just do this. Basically, I'm just going to copy this stuff in, and I'll fast forward this as I do it, because some of it takes a while. Actually, it's not too slow. I think this part is pretty quick. So you should already have Git installed right from the beginning, or at least after you do the update at the beginning. And then we do cd wiring, and that's all there is to that. Actually, didn't take very long. And when it finishes, it says to compile programs with wiring BP, should be OP. Looks like they forgot to change it. You need to add to link to wiring Pi, and I found you also need to link to pthread for a lot of this stuff as well. So let's take, one other thing that is quite handy is this GPIO read all command here, which we'll have a quick execute of. Read all, and you'll notice at the top of this it says Orange Pi PC, but when I run this on mine, it'll say something else. It says Orange Pi Plus. Oh, that plus is just part of this. So my one is giving me a little bit different name, and it's also showing me different numberings for these pins. So what we are looking at here is the WPi ones. So on my one, pin 7 is the numbering for the pin that I was wanting to use, which is, if we go back to this picture for a minute, so physical pin 7 is logical pin 7 in the wiring Pi library. So pin 7 is definitely the number that I want to use for this next part. So to start off, what I want to do is replicate the most basic Arduino sketch that I think we all start out with, the blink sketch, and all this does is it defines a pin as an output, and then it takes that pin high and low repetitively forever and ever at 1 second intervals. So the functions that we're using here, pin mode, digital write, and so on, these have been ported over to this wiring OP library, and there's only a few lines that need changing. I'm just going to copy and paste something that I prepared earlier in here. I'm going to make a file called test cpp and paste in my stuff there. So this is the program, and you'll see that most of it is very similar. The differences are that we need to include this wiring Pi header, and then instead of having a setup function and a loop function that goes on and on forever, like these two, we have to make a main function. So this is the main entry point for when the program starts. Then we have to call wiring Pi setup, and then to make an infinite loop, instead of having it like that, we need to manually make a loop like this that's going to run forever. But the rest of it is all pretty much the same. So over here, to compile that, I'm going to do GCC and then the I've got to save this file first, don't I? Save it. GCC test.cpp, and then I'm going to call the output file just test, and then I have to link, as we were told just before, we have to link to something called wiring Pi, and yeah, I thought so. We also have to link to pthread library as well. Oops. Oh, like that. And that should enable us to compile the program. So now we have this here as our program, and if I run this just like that, it's not actually going to do anything because need to be root, I think. So let me just give it a quick try. Oh, it actually tells us we need to be root. That's nice, isn't it? And let's see if we can. Here we go. So should be able to see that that is turning off and on. Yeah, basically it's just going to run like that forever until we hit Control C in the terminal. So that is, I hope you'll agree, is pretty simple. And the nice thing about that is that you can bring a lot of your old existing Arduino code straight into this and have it run, provided you know what pins to use and so on. By the way, there's a whole bunch of examples in this GitHub source tree. So if you click on wiring examples. So this blink.c is something that I looked at to figure out how to write what I just showed you there. And for the next part of this, I want to look at using a serial connection. So this serial read.c was what I based my next example on, and I've just changed it a tiny little bit because I want to use a 9600 board connection, and I'm using a different device name. But other than that, I think I'm just going to show you exactly what that is. By the way, I had to put a fan on here. I just have a little 5 volt, well, it's a 12 volt fan, but it's running at 5 volts, so it's just blowing a little bit of air across here because it gets a little bit hot and it starts to slow down. So when you're trying to type something in the terminal, it doesn't respond. And I found that if I put my finger on the chip there just to cool it down a little bit, it would suddenly spring back into life again. So I think it does get a little bit hot fairly easily. Anyway, so let's take a look at another example. I will make another file called uart.cpp, and I will paste in basically what we just saw in that GitHub example, except I've changed it to 9600 board, and I'm using TTY-S1. And I just sort of fiddled around and found this by trial and error, but TTY-S1 seems to be the UART 1 pins there, and TTY-S2 is that one there. Actually, I didn't try that one, but I presume that will be TTY-S2 over there. Now this, if we look at sort of an equivalent thing in Arduino before we move on, in Arduino you do something like this: serial begin and then 9600, whatever baud rate you want. And then you do something like this while available read, and then do something with the bytes there. So for the wiring pi library, it's a little bit different. We declare this thing here, which is a file descriptor, and we need to pass this to all functions that are associated with reading and writing from that serial connection. So we first obtain it by calling serial open, and then we give the device name and the baud rate. If it doesn't work, we can print out an error there. And then again, we need to manually put in some sort of a infinite loop to keep this program running, otherwise it would just exit. So what we're going to do is serial get char, which is like, it's a little bit like serial read. So it's similar to this, except it's going to block. So it's going to wait for something to show up, otherwise it won't just continue if there's nothing there. It will wait for something to show up. Actually, I'm not sure if the Arduino does that. Maybe it does that as well. But anyway, that's sort of how it works. That's the equivalency. And I'll just save that file, and we'll also compile this, except we're going to call this one UART, and we're going to compile the file UART CPP, should be okay. And now if we want run UART, I'm not sure if we need to be root for this, do we? Okay, we don't need to be root for that one, apparently. So this is just the GPIOs that you need to be root for. So now what we're looking at here is obviously the this GPS module. It's upside down, so it's not getting a proper fix. Oops. But we can at least see that it is connected, and it's giving us some sensible information to the Orange Pi. So from that point you can again start using your old Arduino code, and you have to change a few things. Like I said, you know, these function calls are a little bit different, and just before we move on, I'll show you where you can find those. So if I go back here, from this folder, if I go into wiring pi, and down the bottom somewhere I discovered wiring serial. This is the two files that define how this all works. And in here we can see the functions that are available to use serial connections. So you can do a similar thing to have an Arduino-like serial available, and that is, in this case, it's called serial data avail. And for each of these, you need to pass the file descriptor of the serial device that you are trying to talk to. And yeah, so there's a few versions of those, and I haven't actually got much further with this than that, but I'm quite pleased that it all seems to be working very nicely. Now, for the JavaScript version of that, we need to do a little bit more setup, and I think the idea is you're supposed to be able to do this: apt get install nodejs, or I also found that if you do npm, I think it's supposed to work if you do either of those, but I had a lot of problems with that until I came across this, which worked for me. So I'm just going to do what we see here, and it's a little bit slow, so I'll have to fast forward this again for you. And once that first part's done, it actually tells us to do this here as root. And this will bring in Node.js and npm, as it says there. And due to even more problems that I had when I was trying to set this up, I had to do more Googling, and found out that basically you need to have the latest version of npm installed before you try and go ahead with any of the other things that we're going to do with the GPIO and the serial port, because we need to get more packages for those, and if npm itself is not up to date properly, then it doesn't work, basically. Now, this one here is very memory hungry, and I found that this one would at some point it hits the limit of memory and everything churns to a very, very slow pace, but it does work if you leave it running. So I'll leave it running here, and I'll let you know how long it takes, because it was probably about 6 minutes or so. Oh, it actually didn't take that long this time. It was only about 2 minutes. That's strange. Yeah, but last time it used up to almost 75% of the memory, and it just took a long time. So after doing that, we should now have Node, and we can check the version of that like that, and we should also have npm. And these are not the latest versions, I think, but they're new enough for the next step. And the next step is that we need to use npm to install this GPIO package for Node.js, and we do that like that. So it's all pretty simple, isn't it? And this will actually, we don't need to do sudo for this one, I think. And this will give us some access to GPIO pins. That one does not take very long, so let's get ready for this. So the other one that we need is serial port, and this is installed in a very similar way, like that. Very easy once you've got all the right versions in place. And this might look bad at first glance, but these are all just warnings, and I found that they don't matter. And again, after installing the serial port package, we have some more warnings, but I think as long as you see this plus serial port version 5 kind of line at the bottom, then I think it's okay. So let's start with the GPIO first, and I don't know all that much about Node.js, to be honest. I'm quite familiar with JavaScript as a language, but this is my first experience with Node.js, apart from writing a very, very simple server. So I'm just going to skip straight down to this example, and again we have basically the blink sketch from Arduino. We're cycling the voltage every half a second. Now he's put a bit more of a complicated example in here because he's got two LEDs, and one is watching the other one, and when the first LED goes on, the second LED will go off, and he's using this change event to let the second LED do that. I'm just going to show you a little bit more simple example that I wrote earlier, again, so Emacs. This time we'll do test.js. There we go. Alright, so we require the GPIO package, and then we just have a couple of variables to store our GPIO itself, and a timer that we're going to have to actually don't need to use that later. I've cut down a little bit of this, so maybe we didn't need that after all. But anyway, we set this on to pin 6. Now, as I mentioned earlier, we're not using 7. Now, it seems like when we're doing this with Node.js, we need to use this orange label numbering there. So I'm using pin 6, and I just have a timer that waits for 1 second, and then it will set the pin, and it will start another timer for half a second, which will reset the pin, in other words, turn it off. So it's going to be on for half a second every second, if that makes sense. So save that file, and to run that we do node, what did I call this? Test.js, I think. So let's just see if I can show you this at the same time, and hopefully it will work. Does not work. I wonder, do we need a sudo for this one again, because it's GPIOs? Okay, that's it. So it looks like GPIOs always need to be running as root if you want to use them. And that's it. It's just a blink sketch. So again, to quit that, we can do Control-C. Now let's have a look at an example for the serial port. So there are some examples here. Alright, down a bit further. So opening a port is just like that. If you want to read from a port, here we go. There's a couple of examples of reading from a port here. One of them, this first one here, will actually cause an infinite loop to occur, so the program's not going to finish if you enter there. I don't know why they call it flying mode, because it's more like blocking mode, or it's like a blocking call, as most other programming languages would call it, I think. So I'm going to show you an example that just does that. It's just going to open a port and then do that. And I have that again on my cheat sheet to the side here. So let's make now a file called UART.js, and I'll copy in my previously written stuff like this. So you can see it's kind of what we saw there on that web page, and the differences are I have said that it's going to be 9600 baud. That is actually the default, but I just wanted to show you how you can set the baud rate explicitly. And again, I'm using this device TTY-S1 because that's my UART1. You can also give a error function to display something if the connection goes wrong, and then basically I just have this down here, which is going to print out something to the standard out every time we see some data coming in from, in this case, the GPS module. You'll notice that I've used console log here, which also prints stuff out to the standard output, but I've used process.standardout.write here, and the reason I did that was because console log will put a new line character at the end of every time that it runs. And I didn't want any spurious new lines to be coming into the GPS output that we see. I just wanted it to be purely only the bytes that are coming in from GPS, so that's why I've used a slightly different one there. So now we can run that with UART.js. What is this? Oh, you have to save these files, don't you? That's the thing about files, you've got to save them before they get written to disk. Okay, so basically it's the same as what we saw with the C++ example. It's just conveying or relaying everything that comes from the GPS module to the terminal. And again, that's about as far as I've got with this. I have not written any cunning stuff to use the UBX protocol. Actually, with the C++ version I did, because I could just use my old Arduino code for that. But I'm thinking maybe to, first thing I'll do next is to convert my C++ UBX protocol stuff to this JavaScript, and we'll see how that goes. So think I'm just going to end that video there, and all the links to all the stuff that I used will be in the description, and I'll paste a little bit of my cheat sheet that I've used to write a script for myself to do this again in the future, and with all the sketches that I just showed you as well, the programs. So have a look at the links in the description if you want to see any more of this stuff, and you may be seeing more of these on my channel in the future. Although I think, to be honest, in the future I won't be getting any 256 megabyte versions. I'll get the 512 megabyte memory ones, because they're only a few dollars more, and I already have, like I say, I already have discovered a few sort of grinding halt situations that I wasn't too happy about. So get the 512 meg version is my recommendation. Anyway, that's enough for now. Thanks for watching. See you next time.